See, nothing is in front, so there is no LED on, but as soon as my hand will be detected, LEDs will turn on. Now I place my hand at around 10 centimeters. See, the LEDs turn on. See, now the obstacle is gone. See, the obstacle is detected, hand is in front, it's gone. So as soon as my hand comes in front, the obstacle is detected and LEDs turn on. See, it's gone. Now see, hand is in front, LEDs are on. I remove them, it's gone. See, it's simple as that. Hello guys, welcome to learning microcontrollers. In this video, I'm going to show you how you can interface a keys KY-032 IR obstacle detection module with a PIC16F877A microcontroller. So let's get started. So guys, this is our keys KY-032 IR module. It looks like this. So guys, as you can see, it has like here an IR receiver. You can see that, and then we have an IR LED, but it's the part of the module. Then we have here an IC. Then here there is an enable pin, connecting enable pin to the jumper connected to the enable pin, and then we have this potentiometer and this potentiometer. Now before you do anything else, for maximum range at 5 volt, just rotate these potentiometer to the anti-clockwise maximum direction. The maximum anti-clockwise they can go, that's all. Then you don't have to touch them. Now guys, these 4 pins here, the top one is a ground. If you hold it like this, then we have 5 volt, then we have signal pin, and then we have the enable pin. Enable pin, you simply short it with a 5 volt, it gets enabled. So if you want to save the battery, like your project has very limited battery, then you will also connect the enable pin to your microcontroller, and you will only enable the module whenever you want to use it, else you will not enable it. But in our applications, this enable pin is mostly connected to the 5 volt because it don't takes that much amount of current. So guys, let's continue. So this is our PIC16F877A microcontroller having 40 pins. It's a DIP version. And guys, this is the keys KY-32 module. And now guys, let me show you how to connect it with a PIC. So first we have a ground pin, then 5 volt, then signal out, then enable pin. Now guys, for the ground pin, connected directly with the ground of the PIC like this. For the 5 volt, connected to the VCC pin of the PIC like this. Now for the signal pin, this is basically a digital signal. It will be either 1 or 0. So you can connect it to any available digital input output pin of your PIC. So I'm going to connect it to pin number D0 like this. Whenever something comes in front, this signal will either send a 1 or 0. So by default it sends a 0. Whenever something comes in front, it sends a 0. So you have to program it like you program a button sending a 0. So whenever 0 arrives, it means an obstacle has been detected, and when there is 1 at the pin D0, it means that no obstacle is in front. Now for the enable pin, just connect it with the VCC pin of the PIC like this. In this way our connections are completed. Now guys, for the purpose of demonstrating the output, I am going to use 2 LEDs, one LED like this. One pin is the longer, one pin is the shorter. Longer pin is the power, shorter pin is the ground. You connect the ground pin directly with the PIC. For the power pin, you use a safety resistor. 220 ohm is enough. Connect your power pins one end to the 220 ohm resistor. Then from the other end of the 220 ohm resistor, send it to any available digital input output pin. I'm going to use a pin number B5. Then another LED, just to add the beauty to the project, I'm going to use 2 LEDs. Again, do the same. Longer is the power, shorter is the ground. Connect the power pin to the one end of the 220 ohm resistor like this. Now again, use any digital input output pin. I'm going to use the pin number B6 for this LED. And again, the ground pin will go to the ground like this. In this way, our IR sensor is connected and LEDs are connected. So whenever an obstacle will be detected in the path, then these LEDs will turn on. So that's a simple, this will be a simple project. Whenever any obstacle comes in front of it, these LEDs will be turned on. So let me introduce you to the hardware before we get to the programming. So guys, this is the hardware. This is our sensor here. You can see that. This is IR transmitter LED, receiver LED. Then these are the LEDs. These 2 LEDs will be used. There at the back is the PIC16F877A, and that is PIC 3.5 programming tool. So this is simple hardware. As you can see, there is a scale just to show you that at 10 centimeter, the obstacle will be detected here or somewhere here, like here. The obstacle will be detected nearly at this point. So let's get to the micro C for PIC programming. So guys, let me zoom in for you so you can see better. So let me zoom in. I go to 300 zoom. First of all, the version for the micro C for PIC I am using is 7.2.0. Latest 7.5.0 is available, and even the latest is available when you watch this video, just go for the latest one. Latest is always better. Click on File, New Project. This window will pop up, New Project Wizard. Click on Next. Write the name of the project. I write IR obstacle tutorial keys learning microcontroller, like this. Just a random name, and then the project folder. I'm going to use this, and microcontroller we are using is PIC16F877A, and the crystal I'm using is 20 megahertz, like this. So guys, click on Next and finish. Now guys, before you do anything else, the first thing you must do is to save your work. Press Ctrl S to save your work, like this. Now guys, the next thing is we have our two LEDs at B5 and B6. Initialize them. Trace. Write down trace B.F5 equals to 0. Like in case of an Arduino, it's like digital pin mode output or input. Here it is a trace register, and 0 means it's an output and 1 means it's an input. Now the initial state of the LED at B5 must be off. Port B.F5 equals to 0. Initially the LED must be off. Now give some initialization delay. That's not necessary, but I prefer you give it in the one time loop for 10 milliseconds. That's all. Now for the second LED, that is at B6, I simply do the same for B6. That's all. Now guys, we have our, you can say the output of the module is going to this D0 pin. As you can see, it's D0 pin, the signal pin. So we have to initialize this pin as the input pin, because the output of the sensor will go to this pin. So to make it an input pin, just copy this, place it here, make it D, pin number 0, and now there will be a difference here. Like for LED it's output, for this it's input. Like again, this is the same command as in Arduino is pin mode. It's like pin mode, pin D0 1, it means that it's now an input pin. For the LEDs we need an output pin. Now for the signal we need an input pin here. Now initially, whatever as I had tested it before, this module sends a 0 whenever an obstacle is detected. So if the obstacle is detected, we get a 0. So initially our our pin must be at 1 state. If the sensor was sending 1, then our initial state of the button must be 0. But right now the sensor is sending 0, so initially it must be at 1. So we can check the difference. So now we simply go to the forever loop. We have our both the module and the LEDs initialized. Forever loop starts here and here. This is a start and this is the end. Now inside it, write down if port D.F0 double equal to 1. Oh, sorry, 0. If the sensor has detected an obstacle, and now we give some debounce, that if an obstacle is detected, like you can say accidentally, or it's too small value, like some fly has passed by or something like that, then this must not be counted. So you can change this delay depending upon the requirements. So I give it like 50 milliseconds because I'm only going to detect my hand. So if my hand is in front of the sensor and still after 50 milliseconds it is still there, it means a hand has been detected. Then what it should do, it should turn on both of these LEDs which are at 0 by default. B6 will turn on and this B5 will turn on. Like this, both will become 1. Now close the brackets of both the loops, this one here and this one here. Perfect. Now if the obstacle is detected, both the LEDs will turn on, and if nothing is detected, then both the LEDs will turn off, like this. So by default the LEDs will be off, and if the button is pressed, only then they will turn on. So we make them 0, like this. Now guys, this is a simple code. Let's build it and burn it into the microcontroller and see what happens. See, build successfully, no errors. Let me get to the PIC3 programmer software. This one, I go to file, import hex file. This is the file. Double click, I click on write. Okay, the new code is being written. Let me zoom out and we go to the hardware. So this is the hardware here, and let it burn. Okay, the new code is burned. We power it up using this PIC3 programming tool. I click on. Now take a look here. By default, their LEDs are off. So that's perfect. Now I will bring my hand in front of it. See, LEDs turn on. I remove it, it turns off. So it is like a 10 centimeter You can say that it starts like I move my hand near from far away. Then you will see that at around nearly 15 it starts to blink, and at 10 centimeter it perfectly detects the hand. See, so you can say that it's like 12 centimeter of maximum. See, at 15 to 16 centimeter it will start blinking, and when it's come near to, like I call it, like at 10 centimeter it perfectly detects an object. So it can detect an object at 5 volt of transmission power at 10 centimeter. You can increase the transmission power of this LED by giving it an external supply, remember that. But in such a module it is like maximum range is like 10 centimeter, like this. See, I have another video on obstacle detection as well, in which I had not used a module, I had directly used these two LEDs. And there you can give power to this transmitter LED yourself using like 12 volt supply. That will greatly increase the speed. So in this module, like range will be like a 10 centimeter. At 10 centimeter an obstacle is detected. So see, it's simple as that. Whenever hand comes in front, it detects the obstacle. See, it detected it. Now it's off. Hand detected, it's off. Detected, else it's off. So guys, this is it. It is simple as that. So guys, thank you very much for your time. If you have any questions, you can ask them in the comment. So right now, have a nice day until the next video. And all of this code, you can play with the code. I will give you the code, and all the micro C files, including the hex file, C file, will be in a Google Drive link that will be shared in the description of this video. You can open that link and you can download all those files, and then you can play with this code, etc. So guys, goodbye and have a nice day.